Okay, so we've talked about inductors. Let's talk about some capacitors now. And we're going to go through RC series circuits, and then RC parallel, and then some of the combinations perhaps. So let's begin. So some of our objectives are calculate total capacitance, calculate total capacitive reactance, because just like with inductors, we have something magical, so to speak, not really, but physically altering, it's way early in the morning, physically altering the current as it goes through. And we're going to do that by calculating impedance, so nothing changed there. And capacitors are used for various things: power supplies, amplifiers, tuning circuits, filters, and you'll see a lot of those filter capacitors. And so they're going to change what happens in the circuit. We need to kind of understand what happens there, and how it affects current and the overall circuit operation. So that's what we're going to be studying this morning, or whatever time you happen to be viewing this video. So let's dive right in. Alright, just like resistors, the total capacitance of a series circuit is always less than the smaller. Now that's backwards to resistors, because in resistors it's in parallel that the overall value of the resistance is always lower than the lowest resistor. Well, capacitors are a little different. Capacitors in series actually form a capacitor that is lower than the lowest value. So it's just the opposite of resistors. You have to remember, for capacitors, that holds true when they're in series. So if we've got a 10 and a 20, our overall capacitance is 6.6 microfarad. And if you notice, both of those are in microfarads. So basically, we're just spreading those plates further apart. So if we have two of those in series, the circuit just sees that as one capacitor, or overall capacitance there of 6.67 microfarads. And the greater the distance, the lower the capacitance. So the farther apart we get, the lower we get in capacitance. So, and the junction between C1 and C2 is essentially neutral there. So basically, it's like one big capacitor. Total capacitance of the circuit is felt between the left plate of C1 over here and the right plate of C2. So again, it's like one giant capacitor as far as the electrons are concerned. And we use the same formula. We use product over sum. And we can use a reciprocal if we have more than two. If we get into more than two, I may show you that. If not, if you have interest in the reciprocal formula, you can Google it or ask your instructor. I'd be happy to show you that. But if we use product over sum and we have more than two, we have to do two at a time. For instance, if there were a C1, C2, and C3, we'd have to get the CT of C1 and C2 and then combine it with C3. So that's something to remember with product over sum, something we don't have to do with reciprocal, which is why I favor it. So again, they're showing how we arrived at that 6.67. I'm not going to go through every step. You can pause the video and actually do that math. But basically 10 times 20 over 10 plus 20 gives us 200 over 30, which ultimately gives us that value. So you should know product over sum by now. If not, we missed something in DC. It'd be a good time to revisit that as well. Alright, so we got a 3 and a 6. I can do this one in my head. Product over sum, 3 times 6 is 18. Add them together, that's 9. 18 divided by 9 is 2. Never hurts to use a calculator. I'll come over here. 3 times 6 equals 18. Divided by, and we'll say 3 plus 6 equals, and that's one of the fallacies of using a calculator that's not a scientific. Let's change over to our scientific, because we need our parentheses. 3 times 6, and we'll do it equals, and then we'll say divided by, and we'll open parentheses, 3 plus 6, and that makes sure that we do the parentheses before we do the division. So that gives us 2, which is what we started with, and that is the correct answer. And here is the total capacitance, which I said had more than 2. So I'll quickly show you how we can do it, product over sum wise, and I'm still using this new pen thing. I'm still trying to get used to it. It's been a while, so I'm sure it'll be a little wonky as I first try to get there, but please bear with me. We'll see if we can get this right. So 3, we're not writing. I'll pause the video and find out why we're not writing. Be right back with you. Okay, we're back. Got the pen enabled here, so we can do what we need to do. So again, I'm going to do C1. Again, I apologize as I'm getting used to this. I don't know why I'm kind of writing sideways. C1 and C2 is what I'm trying to write up there. That looks a little better, maybe. So if I do 3, I'll press the button on the pen. 3 times 3. I think it's the orientation on my board. Let's see if I can straighten that out a little bit and see if that keeps me from being a little wonky. 3 plus 3. So that equals 9 over 6, which equals 1.5. Well, I was wanting to write italics. I'm doing a very good job of that. So anyway, C1 and C2's equivalent is 1.5. 3 times 3 over 3 plus 3. So I've done these two. Wow, that's a perfect circle for sure. But you get the idea. I've done those two right there. And now we've got to do it with the last. So I'm going to come over here and I'm going to write 1.5. It's pretty spread out, but we get the point across. Over 1.5 plus 3 equals, and I think I know what's going on, so I'll fix this after we calculate this. So that equals 1.5 times 3 is 4.5, and 1.5 plus 3 is 4.5. So this is C1 and C2's equivalent along with C3, which gives us 4.5 over 4.5, which gives us 1. So we got the answer over here. It is 1. But I'm going to show you just how quickly you could have done that using the reciprocal formula just on the calculator. This will only take just a moment. Let me move the calculator where you can see, and then we'll clear all this and come back. So we've got 3, and what we have to do is take the reciprocal. And I'm not sure if this scientific has a reciprocal, but I know the standard does. So I'll switch to it, and it's 1 over x. So simply 3 reciprocal plus 3 reciprocal plus 3 reciprocal, hit equals, and then reciprocate that, which reciprocal 1 is 1. That's why we came up with 1. So reciprocal formula is much faster, but anyway, the answer is the same. You can see we got it correct. It is 1 right there. So pretty easy to do, more than 2 if you need to, using either product over sum or reciprocal. I just personally prefer the reciprocal because that's how I did it 150 years ago when I was in college. And this is old habits die hard, as they say. So that was that problem. So now we're going to discuss capacitive reactance here. X of C is measured in ohms and expresses the amount of opposition to current flow. So remember X of L with inductance, we've got X plus C in X of C in reactance, and that's what we're going to look at today. And it's caused by the capacitance and the frequency. So again, just the same way we had an X of L that was related to inductance and frequency, we got an X of C related to frequency as well. Capacitance describes the charge stored by a capacitor. The greater the capacitance, the larger the stored charge. So the bigger the capacitor, the more it can store right here. AC voltage causes electrons to move from one plate to the other. The more electron movement, the higher the current, as we see. So if we're moving more electrons, we're going to have a higher current. As capacitance increases, current increases, and capacitive reactance decreases. When you think about that, it makes sense. Capacitive reactance is basically an impedance value, and if it drops, current is going to rise. And we see that as current rises, so does capacitance as well. So we get larger in that respect too. Frequency is measured in cycles per second. That's hertz. The more cycles per second, the higher the frequency. At higher frequencies, more cycles or waves pass through a given point. You should know that. We're 1 hertz. 2 hertz is literally twice as fast as 1 hertz. That's 1 full cycle in a second. 2 hertz is 2 full cycles in a second. And as frequency increases, current increases, and capacitive reactance decreases. So they are inversely proportional. So as we go up in frequency, we should go down in capacitive reactance, and that's because it's buried under this on the denominator side. And so as we go up, our value will go down. So if we take a look at C1 being 30 microfarads, we have to apply 1 over 2 times F, which is frequency, 2 pi, frequency, and then capacitance. So everything you see here is sorry, lost my train of thought. But anyway, getting back to this, 2 pi is 6.28. Frequency is 100 hertz, and capacitance is 30 microfarads. And if we do that math, we come up with 53 ohms. So let's do that on our calculator. I'm going to clear my calculator over here. And I'm going to, since we got the reciprocal button, remember reciprocal is just taking 1 and dividing it by whatever value you arrive at. So all I've got to do is the 2 pi FC and then reciprocate it. So I'll say 6.28. Well, it helps if you don't hit clear. Let's try that one more time. 6.28 times 100 times 30 equals, and we got 18,840. Now you might be wondering why we got such a large value and they got such a small value. Well, I wanted to do this for that very reason. Micro means divided by what? You know, milli means divided by 1,000. Micro means divided by what? So we've got to convert this to micros. We can do that after the fact, or we can do that before, but it basically means divided by 1 million. So there's 1 million equals. Now we've got the same answer. So basically when we're using this 2 pi FC, we've got to use base units, hertz and micro, unless these units happen to cancel. For instance, this was megahertz, which is times 1 million, against microfarads, which is divided by 1 million. Those would cancel out. We wouldn't have to worry about converting units. But if we've got mixed units that don't cancel, we're going to have to take that into consideration. So if I invert that, I get 53 ohms, as you see there. So it looks like we're about out of time for the first video. We'll continue on here. And if you're having trouble with the metric system, now is the time to speak up, because should have got that in DC, but if you didn't, let's talk about it. So I'll start with the next video just in a moment. And as always, if you have questions, please see your instructor.